So, my name is Ali Aman. This is my LM9 Teach One about entity relationship diagrams, perhaps 671, and Dr. Savitra George Mason. So, getting started, my presentation, like I said, is about entity relationship diagrams. So, to get started, we will talk about what are entities. An entity can be thought of as a class of data. Each data has a name, each entity has a name, a definition, and a type. They also have a set of attributes that describe various characteristics of this entity. Each attribute has a name, definition, type, and constraint. And the attribute types are text, numeric, binary, and date types. Field and attributes are different names for the same thing. An entity and table are different names for the same thing. So in the context of relationship diagrams, the word entity and attributes are used. In the context of a physical database, words table and field are used. So just a quick overview, what is the purpose of an ERD or an entity relationship diagram? And the reason we use these is to help you prepare the structure of a database. An ER diagram is a list of these entities and their relationship with one another. So explaining their relationships, there are a few different types of relationships possible. Actually, there's three. A one-to-one relationship where one entity corresponds to exactly another entity. A one-to-many relationship where one instance of one entity can be repeatedly used for another. And then a many-to-many relationship where one instance where both entities can be repeatedly used for another. So an example of a many-to-many relationship would be like tables that are patient and physician, because one physician may have many patients and one patient may have many physicians. So it could be a many-to-many relationship there. And then just quickly going over some of the elements that are used in these ERDs. So the symbol for an entity is that rectangle. A relationship between them is that kind of diamond. And then they have different attributes. So attributes are used to describe the characteristics of entities. For each attribute, there is a set of values. They're called domains. So in an ER diagram, an attribute is represented by that oval that we see there. And there's different types of them, like we can see. So there is a multi-valued attribute that can possess more than one value in an instant of time. There's the single valued attribute, which can only have one value at a particular time. There's a composite attribute that can be further divided. And this is like an example is a person's name could be like divided into first name, middle name, and then last name. And then the bottom two are just examples of like what a weak entity and a weak entity relationship. And those are just like a double of what the original is. So like a rectangle is two rectangles, or a diamond is two diamonds. Next, we're going to talk quickly about cardinality and relationships. So a relationship between two entities, it like shows how they're associated with each other. And the cardinality defines the possible occurrences in one entity, which is associated with the number of occurrences in another. So in our diagrams, they're represented by a crow's foot at the connector's ends. And like it's the same three common cardinal relationships, which is one-to-one, one-to-many, excuse me, and many-to-many. All right, now we're kind of moving on to our LM9 assignment. So just quickly going over the first part of the assignment, where it asks us to create a many-to-many relationship between patient table using identifier, patient ID, first name, last name. So this is the table. I just put create table, and I called it patient table. And then we use the IDs that they give us, a patient ID, first name, last name, and then primary key. And the primary key for this would be the patient ID. And then you insert into the patient table, you type in the values, I just came up with a couple random names, starting with mine, and then gave each one of them a specific patient ID. So 1, 2, 3, 4, 5. And then when you select from the patient table, that's how the output should look. You have first name, last name, and then each person with an individual ID. And then the next part, which is creating the address, a table for the address. So we press create table, or sorry, we create table. I just called mine address table. I used address ID, apartment, street, number, and zip code, which is the stuff they give us to use. And the primary key for this table is going to be the address ID. And then same concept, you insert into, you type in, each one has an individual address ID number. Come up with, an apartment complex name, a street name, number and zip code. And then once you select from that table, this is how it should come out and look as the results. And then moving on to the final part where we're entering 5 rows of data into each table, and we want to show that 2 individuals can live at the same address and 1 individual can have 2 addresses, 1 current and 1 previous. So the only difference for this one is we're going to have a person ID and an address ID, and then the other part is going to be a current address and a previous address. So the same as the previous table, you're going to create a table. Mine was called current previous address, but just call it whatever you want. And then same concept, insert into the table. So the only difference for this one is, okay, for the first example here, I showed that I gave a person ID, an address ID, the current address, and then this one has the previous address to show that one person can have a current and a previous address. The next one, this one, like the example is just non-point. So that's that person's address. And then the third person who has their own person ID has the same address ID because I gave them the same address as the second person. And then the fourth and the fifth person both have unique person IDs and address IDs because they live at, their own places. So when you run that and the table output comes out, you'll see each person has their own individual person ID. One person has a current and previous address. And then 2 people have the same address ID because they share the same location. And then the last part about this presentation is creating it into a table. So it gives us some Microsoft, I believe it was Microsoft ID that we could use to create a table as an example, but I don't have like the Microsoft software. So I just Googled how to make it. And I ended up using a software called Lucidchart, where I kind of created my own version of the table showing the one-to-many relationship between patient table and the current previous address, and then the many-to-one relationship between the current/previous address and address table. And then the P, I just put next to the primary key. So for patient table, that was patient ID. For the address table, it was the address ID. And then for the current previous address, we had both a primary key as the person ID and the address ID, and they're both also the foreign keys as well. I hope that this helps you guys with the assignment, and I appreciate you guys listening. Thank you very much.